Good morning. My name is Kirtana KS. My topic is the main goal of the project designing a lexical analyzer and parser for mini ATC language using automata theory. In that we discuss about first objectives. Here we learn explain what you learn automata theory basics, lexical analysis, DFA, tokens and context free grammar programming implementation. Here we discuss these are all objectives. Next is introduction. In introduction we learn about what is automata theory, importance in compiler designer, role in programming languages. These are our introduction to automata theory. Next is mini ATC language. Mini ATC language means mini ATC is a simplified language programming language subjected for the programming structure, declaration statements, assignment statements and print statements. These are all mini ATC languages. In that lexical analysis and parser design. We learn about first lexical analysis. Lexical analyzer are the first phase of the compiler. It consists of input program into a sequence of items that are first phase of compiler converts program into tokens like identifier keywords, numbers, operators and so on. Next we discuss Faris design. Here we explain about Faris design means Faris checks grammar correctness, works after lexical analysis, helps detect syntax errors like components or input buffers, token register and syntax task. Next is tokens and rules. Here we explain different token types like keywords, identifier, numbers, operator, delimiters. Numbers means begin, end, int, print. Identifier means most start with the letters and way contain letters. Numbers means only numbers like 1, 2, 3, 4. Negative integers are allowed. Non-negative integers are allowed. Operators are plus, minus, star, bar, etc. Delimiters means column, apostrophes like that. Rules are identifiers must start with a letter. Identifiers can contain letters and digits. Numbers must be non-negative integer. Keywords are reserved or cannot be used as identifiers. These are tokens and rules. Next is regular expression. Regular expression we learn explain used to define token patterns and helps identify valid inputs. Means identifier invalid inputs means identifier number keyword operators like that. Regular expression are used in the textual analysis to define patterns for identifying different types of tokens. Next is finite automata identifier DFA. Here identifier DFA means start and transitions. Here start means Q0 to Q1 here. Start states and final state used for validation. Here start here start means Q0 and end means Q1. Final state is letter or digit. Start means Q0 Q1. States means Q0 and Q1. Start means Q0. Final state is Q1. Transitions are from Q0 to Q1. Input letter A to Z, A to Z. Next is transitions from Q0 to Q1 on input letter A to Z and caps A to Z. From Q1 to Q0 means on input letter digit A to Z 0 to 9 like that. Explanation means identifier must start with a letter. After the first letter it can have any number of letter digit. Next is DFA for numbers. DFA for numbers means numbers contain digits only, not letters. DFA validates numbers. It indicates only the numbers. Identifier must start with the digits. States are Q0 and Q1. Start state means Q0. Final state means Q1. Contains Q0 to Q1. Input state is 0 to 9. Means this is digits or numbers from Q1 to Q0 on input digit also 0 to 9. The number must contain start with the digit is 0 to 9. After the first digit it can have any number of digit like 0, 1, 2, 3 like that, any number of. Example is valid number is 0 0.5, 11 like that, etc. Invalid numbers means ABC, minus 1, 2, 3, or these are invalid. Valid only positive numbers. Invalid means non-positive, non-negative numbers. Next is implementation. Here implementation means Python program, token checking functions, how the code works step by step we learn. Here's code. Here we discuss explanation of the code, purpose of the code. This Python program acts as a simple lexical analyzer for the mini ATC language. It reads the input program and identifier different tokens like keyword, identifier, number, operators, delimiterators. This is the Python. Define is keywords, return s in begin, end, int, print. This function checks whether the word is a keyword. Keywords are reserved words in the mini ATC language. Example begin. This output is keyword. Function of check identifier means define is identifier as, return s means checks whether the variable name is valid. S of 0 dot is alpha. First letter must be a letter. And example is x total sum 2. This invalid is 1 ABC or at name. Function to check number. Define is number. Return a s dot is digit. Checks whether the input contains only digits used to identify numbers. Example 10, 25, 100. Invalid means 12a or minus 45. Display message Python print enter mini ATC code bracket type exit to stop. Display instruction to the user. User can stop execution by typing exit. Infinite loop means while true, returns the program continuously until user types exits. Taking input means s is equals to input, reads the mini ATC program from the user. Exit condition means if x equals exit, break, stops the program when user enter exits. Splitting input into words means words is equals to s dot split, splits the sentence into separate tokens. Input means int x, next int x double inverted comma. Next keyword checking. Next is keyword checking. If is keyword w, print w keyword. Prints token as keyword if matched. Identifier checking means if elif is identifier, print w identifier. Prints token as identifier is invalid variable number. Number checking means elif is number, means print token as a numbers if digits only. Operator means checks arithmetic and assignment operators. Delimiter checking checks special symbol used in programs. Invalid tokens are if tokens does not match any rule, it is invalid. Here we run the program. Here this is the code. We run the code. Enter mini etc code type exists to stop. Here we enter begin. Begin means keyword. Next I enter int. Int means also keyword. Here enter int x or x. This is identifier. Next equals means operator. Like this, these are all the outputs. 10 means number. And also keyword. This is the output of this code. Next topic is test cases. Valid input example, invalid input example, error detection. Here input, output are the text cases. Next is context free grammar. Grammar rules of mini etc, terminals and non-terminals, statement formation. Here context free grammar also, these are the rules. Next is conclusion, what the project achieved, importance of DFA and CFG, real world compiler applications. Next is reference. We refer this books, lecture notes and Python documentation. Thank you.